Compiler Design Module 1 Important Question. Define language processor and explain the different types of language processors with suitable example. Draw and explain the structure of a compiler. What are the different phases and their roles? Explain the evaluation of programming languages and how it has impact on compiler design. Discuss the science of building a compiler. What are the key challenges and steps involved? What are the applications of compiler technology in modern computing? Explain with real world scenarios. Explain the basic elements of programming languages such as syntax, semantics, and programmatics. What is a syntax directed translation? Explain with an example. Define parsing. Differentiate between top down and bottom up parsing with example. Write a note on productivity tools. Write a short note on interpreter. Consider the context free grammar and solve. Show how the string a plus a star can be generated by this grammar. Construct a parse tree for the string. Module 2. Explain the role of lexical analyzer in the compiler. What are its main tasks and how does it interact with the parser? What is input buffering? Explain how buffering is done using the two buffered scheme with a neat diagram. Define tokens, lexemes and patterns with example. How are tokens specified in lexical analysis? Describe the process of recognizing tokens using finite automata with an example. What is Lex? How does the Lex tool help in generating lexical analyzers? Provide a basic Lex program. Define context free grammars. Write a CFG for simple arithmetic expression involving plus, asterisk, and parenthesis. Differentiate between regular expression and CFG with suitable example. Write program to generate a valid identifiers and integer numbers. Show the derivation steps for a sample string. ಈ ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲಲ್ಲಿ ಲೆಫ್ಟ್ ರಿಕರ್ಷನ್ ಮತ್ತು ಲೆಫ್ಟ್ ಫ್ಯಾಕ್ಟರಿಂಗ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಎರರ್ ರಿಕವರಿ ಸ್ಟ್ರಾಟಜೀಸ್ ಮತ್ತು ಟೈಪ್ಸ್ ಆಫ್ ಕಾಮನ್ ಪ್ರೊಸೆಸಿಂಗ್ ಎರರ್ಸು, ಟೋಕನ್ಸ್, ಲೆಕ್ಸಿಮ್ಸ್ ಮತ್ತು ಪ್ಯಾಟರ್ನ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಯರಿ ಕ್ವಶನ್ಸ್ ಆಗಿರುತ್ತೆ. Module 3. What is recursive descent parsing? Explain with an example and describe its limitation. Define first and follow sets. Write the algorithm to compute first and follow for a given grammar. Explain the construction of an LL of 1 parsing table using first and follow sets. What are LL of 1 grammars? List the condition for a grammar to be a LL of 1. Give one example of LL of 1 and non-LL of 1 grammar. What is bottom-up parsing? Explain the concept of shift, reduce, accept and error actions in shift, reduce parsing. Define reduction and handle parsing in bottom-up parsing. How are handles used to perform reductions? With a given grammar and input string, perform shift reduce parsing and show step-by-step parsing actions. Compare and contrast top-down parsing and bottom-up parsing with an example. Module 3 ಅಲ್ಲಿ LL of 1 parser ಮತ್ತು ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಫಾಲೋ ಬರೋದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ. ಅದ್ರ ಜೊತೆ SR ಪಾರ್ಸಿಂಗ್, ಶಿಫ್ಟ್ ರೆಡ್ಯೂಸ್ ಪಾರ್ಸಿಂಗಿಂದು ಸ್ಟ್ಯಾಕ್, ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ ಬಫರು ಮತ್ತು ಆ್ಯಕ್ಷನ್ಸ್ ಬರೆಯೋದು ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ. ಅದ್ರ ಜೊತೆ ಥಿಯರಿನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು. ಹ್ಯಾಂಡಲ್ ಪಾರ್ಸಿಂಗಿನ ಥಿಯರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. Next, Module 4. What is LR parsing? Explain the components and working of simple LR parser. Explain the LR parsing algorithm with the help of an example. Define viable prefixes. How are they useful in constructing LR parsers? Explain the construction of SLR parsing tables using the canonical collection of LR of 0 items. What are syntax directed definitions? Explain synthesized and inherited attributes with example. Explain different evaluation orders for syntax directed definitions, top-down and bottom-up approach. Given a simple grammar and associated std, complete the values of attributes for a given input string. Differentiate between S attributed and L attributed definitions with example. Write std for simple type declarations. Also write dependency graph for declaration int id1 id2 id3. ಇದು float id1 id2 id3 ಅಂತನಾದರೂ ಕೊಡ್ಬೋದು. ಮಾಡಲ್ ಕ್ವಶನ್ ಪೇಪರಲ್ಲಿರುವಂಥ SLR1 ಪಾರ್ಸರ್ ಅದರ ಥಿಯರಿ ಮತ್ತು ಪ್ರಾಬ್ಲಮ್, LR0 ಥಿಯರಿ ಪ್ರಾಬ್ಲಮ್ ಆ್ಯಂಡ್ ಡಿಪೆಂಡೆನ್ಸಿ ಗ್ರಾಫ್ ಥಿಯರಿ ಪ್ರಾಬ್ಲಮ್ ಇದಿಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್. Last module 5 important questions of compiler designs are: what are the different variants of syntax tree? Explain DAG, directed acyclic graph, and their use in optimization. Define three address code. Write three address code for arithmetic expressions and explain the different forms like quadruples, triples, and indirect triples. How are types and declarations handled in intermediate code generation? Explain the suitable examples. Explain control flow statements if else while using three address code format with example. What is a target language in a context of code generation? Discuss desirable properties of a good target code. Explain the role of address descriptors and register allocations in code generation. Given a three address code, generate target code for a simple arithmetic expression or control flow statement. Write STD for flow of control statement. Write a note on simple target machine model. These are all the important questions for compiler design.